Okay, so we're going to finish up these last three questions. E is kind of like a special case. When you notice your denominators are subtraction in the opposite direction, basically what we can do is we can think about the fact that if we had these as a fraction, right, together in a fraction, they would cancel to -1. What we're going to do is choose one of them and factor out the -1. So I'm actually going to work with the second one because I kind of like the 2x being positive. So if I take a -1 out of this, the 2x, which is currently negative, is going to become positive. I'm going to write that first. And the 6, which is currently positive, is going to become negative. So the next thing I'm going to use, I'm going to rewrite it like this right now. And you don't need to do all this rewriting. This is just so we can make sure we understand what's going on. We can use the property of a fraction that if I have a negative sign in the denominator of a fraction, that's equivalent to having that negative sign in the numerator or in front of the fraction. So I'm actually just going to take that -1 or that negative sign, and I'm going to move it up to the top of the fraction. Now we have our LCD, so it's kind of like a little trick in using that fact we know about those subtraction and opposite orders. So now we have 3x plus -9 or -9 over 2x minus 6. Now this one actually does simplify. So this is going to become 3 times x minus 3 and 2 times x minus 3. And this has nothing to do with it being that special case. It just happens to simplify. We can cancel these. And my final answer is 3/2. Moving over to the next problem, we're going to start to look at things where one denominator is a factor of the other denominator. So these are both binomials, but my LCD doesn't need all of both of them. So I'm going to factor the second denominator. So since they have a matching factor of the x minus 3, my LCD, we're going to need an x plus 3, and we're also going to need an x minus 3, which in simplified form is x squared minus 9. My first fraction is missing the x plus 3. And my second fraction is good, it has both of them. So I'm going to distribute this out now. So my first fraction becomes x squared plus 3x. When we multiply out those denominators, we know that that's x squared minus 9. And my second fraction stays as it is, 18 over x squared minus 9. Putting these two together, now that they have that common denominator and are like terms, so from here, we're just going to see if these factor. It looks like a trinomial with a potential to factor in the numerator. I know my denominator factors into x plus 3, x minus 3. My numerator, numbers that add up to 3 and multiply to -18, are positive 6 and -3. So now we see we have that common factor of x minus 3. So this final answer is x plus 6 over x plus 3. The next problem is going to be similar, letter G, except now I have, instead of having that difference of perfect squares denominator, I have a trinomial. So I'm going to factor this trinomial, adds up to 2, multiplies to -8, is positive 4, -2. We see that matching factor. I'm going to erase this so we can write our LCD over here. So my LCD is x plus 4 and x minus 2. Or multiplied out, we know is x squared plus 2x minus 8. First fraction is missing that x plus 4. So this is 5x squared plus 20x over x squared, right, we're going to use this, plus 2x minus 8. And just a side note, the reason I always multiply these out, I could leave them factored, is that usually when you leave them factored, you end up forgetting how to add it. You end up canceling stuff when you shouldn't. Having it simplified is better. Second fraction is still just 6 over x squared plus 2x minus 8. So now I'm going to combine my like terms. I have 5x squared plus 20x plus 6 over x squared plus 2x minus 8. And looking at this quickly, this is one of those where I'd have to bring up 5 and 6 together to make 30 if I was going to factor it. No factors of 30 add up to 20, which is that middle term. So we are done. And that is our final answer. So big idea here, when we add fractions, we need common denominators. The only way we can make common denominators is through multiplication or multiplying fractions by 1. Same thing in the numerator with the denominator.